Hello, welcome to the JavaScript program written to accompany my last lecture on the use of probability theory to handle uncertainty in decision making. This is a framework for an expert system based loosely on probability theory. I say framework because it doesn't have any rules built into it as such. The expert system is accompanied by a simple rule editor, and the idea is that you use that to construct your own expert system, then use the main program to run it. I won't concentrate too much on the editor, particularly as it is fairly basic in its operation. The expert system you create consists of a series of what I term entries, each of which can be a question that the system can present to the user, or a rule that can infer something from up to 3 other entries. The screen shows the editor after 2 entries have been created. The first is a question that, when the expert system is run, will present the user with a statement, "The temperature in the reactor core is increasing," and ask the user to rate it on a scale from 0, impossible, to 1, certain. The second entry is an AND rule that takes its inputs from entries 3, 10, and 14. These 3 entries don't exist yet, but they can still be referred to in an earlier entry. This entry is equivalent to saying that if entries 3, 10, and 14 all give true values, then this entry will give a true value also, like an AND statement with 3 inputs, except the whole system is based on probabilities. The fact that entries can refer to other entries you haven't created yet is fine, except it does mean that you will have to plan the entries out fairly carefully before you enter them into this editor. Of course, you can always change the entries at any point. If you want to use the word not in conjunction with any of the entries, then put the entry number in the appropriate text field, but make it negative. If you change that example entry so that it referred to 3 minus 10 and 14, then it is equivalent to a rule firing if entries 3 and 14 were true and entry 10 was false. Of course, in probabilistic terms, this means that we use the probability of entry 10 being false instead of the probability of it being true. Since you can enter an entry number as either positive or negative, it means that the entries must be numbered from 1 upwards, rather than from 0 upwards, which is more common from a programming point of view. Of course, the whole point of an expert system is to draw conclusions. The system as it has been set up has no way of specifying that an entry is a conclusion or simply part of the processing. However, every entry can have text associated with it, and this text is displayed on screen whenever a rule fires. I suggest that you follow the convention of specifying that an entry is a conclusion by putting all the text in uppercase, as shown. That should make the text leap out of the screen at you. Once you're happy with the entries, click on the Save button to convert them into a form that can be saved ready for the expert system itself. The editor writes them all out as plain text and stores it in a text area as shown. Highlight all this text, copy it to the clipboard, and then paste it into a simple text editor like Notepad, so that you can save it to disk. Similarly, if you wish to alter rules from the saved data, you can load them in by pasting the entries into the text form into that same text area and clicking on Load. There's nothing to stop you changing the entry data while it's in Notepad, of course. Indeed, there's no need to use this editor at all if all you want to do is crank out the data. You can simply type it in, providing you stick to the format the expert system expects. This format is as follows. The first line contains the number of entries, with each entry following consisting of an entry type, 0 for AND rule, 1 for OR rule, and 2 for question, the text of the question, and the 2 or 3 possible entries that the entry might refer to, all in separate lines. For example, those 2 rules that I showed before would be saved as shown. If the entry refers to only 2 others rather than 3, just make the third entry 0 so that it will be ignored. Now onto the code for the expert system itself. The screen consists of a text area where you paste in the list of entries followed by a single button, which loads them into the system and then runs the entries themselves until they've all been used. You can't see it, but there's an empty div statement underneath that button called Work Area, in which the entry text will be displayed together with the strength value associated with those entries. The entries are stored in the expert system in the same way that they were stored in the editor, as a series of arrays. For entry type, 0, 1 or 2, depending which type of entry it is. for the associated text, and for the up to 3 inputs, imp1, imp2 and imp3. Unlike the editor, we also need an extra array called prob that will associate a probability value for each entry as it is run. The starting value of -1 indicates that the particular entry hasn't been successfully run yet. Once it has been run, the probability value will range from 0 to 1, just like normal probabilities. The string variable s will contain the text for all the rules that run together with the probability, or strength value if you like, for those rules. This will build up as the program runs and will be displayed in work area every time a rule fires. The variable SUMRuleRan is used to loop through the rules repeatedly. That variable is set to true whenever a rule runs, and the loop persists until it remains false throughout an iteration, i.e. the code only terminates if and when there are no rules left to run. I've also set up 3 constant values so that I can refer to the different entry types easily. The button calls the one large function in the program. This has 2 parts, the first of which is to load the entries into the system, done using pretty much the same code that the load function in the editor uses. The contents of the text area are turned into a string in variable s, which is split up using the split method built into strings, and the line break character as the line separator. The individual lines are stored in variable lines, with the first one being the number of entries, and all subsequent lines being the entry data itself, in the same order as before: entry type, associated text, and the up to 3 associated entry numbers. This part of the function also counts how many of those entries are questions, and stores it in the value numQuestions. This is so that when the questions are presented to the user, it can display how far through the questions the program is. It's a lot better when presented with a question to know that it is, say, question 6 of 10, rather than have the prospect of an unknown number of questions to follow. The variable IDX is used to step through the lines of extracted text. Every time it is used in setting up an array value, it is incremented automatically by 1 afterwards. Rather than having to do this using 2 separate code statements, languages like JavaScript and C++, let us combine them into one line, so the ++ appears as part of the array index itself. The second half of the function is the part that scrolls through the entries, asking questions and running rules. Variable q starts at 1 and increases every time a question is asked, so that the screen can report its question 1 of 6, 2 of 6, and so on. A do-while loop is then used to go through all the entries, and variable SUMRuleRan is set to false at the start of the loop. If any entry is run on that pass through the loop, then the variable is set to true, which means that a probability value somewhere in the system has changed, and it's worth going through the list again to see if something else changes. Basically, that loop runs until a pass produces no change at all, in which case all the logic is played out. A test is carried out to see if the probability value for any entry is -1, meaning that it hasn't managed to run yet. If so, then the expert system tries to run it, i.e. asks the question, or run it as an AND rule or an OR rule. If any of those strategies succeed, then SUMRuleRan will be set to true, and that rule will have shot its bolt. A question is asked using a JavaScript prompt box. The statement is presented on the screen, and the user is asked to what extent he agrees with it, by entering a number from 0, no, it's completely wrong, to 1, yes, certainly, with 0.5 in the middle meaning equally likely yes or no. Both AND rules and OR rules are handled by the same function, as the code is very similar for both, so a single parameter, isAnd, distinguishes between the two. The 3 inputs are copied from the arrays into variables first, second, and third for convenience. The rule will either be a 2-input rule or a 3-input rule, depending on whether the value of third is non-zero or not. Either way, we are going to need the probabilities for the first 2 inputs to be stored in variables prob1 and prob2. Of course, if either of these two is -1, then this particular rule can't fire at this point. Better luck next time round. We can't just read the probability straight from the prob array, as first and second might be negative. For this reason, we need a special function, getProb, to extract that probability. If the array index is negative, then the value returned is the probability of not the input, i.e. 1 minus the probability stored. Here's the code for the two-input version. For AND rules, we assume that the two inputs are independent. What else can we assume? So we just multiply the probability values. If it's an OR rule, then we add the two probability values and subtract the probability that they both happen at the same time. These are just the standard formulae for the probability of A and B, and A or B, that you learned in maths classes. After the calculation, the function displayRule is called to display the text of the rule on the screen using string variable s, plus the probability calculated to 4 decimal places. This function also sets the variable sumRuleRan to control whether the main loop runs again. The code for 3 inputs is similar, but a little more involved. For a start, we need a third probability, calculated as before. If it's an AND rule, then we just multiply the 3 inputs as before, assuming independence. However, the 3-input version for the OR rule is much more complicated. You might have learned probability theory in terms of Venn diagrams, in which case sit down with one of 3 circles overlapping and match the formula that you see here to that. It all works out. There you are. That's the code explained. Using this system will show that the whole thing does not follow the strict rules of probability, as the values calculated for the conclusions typically either add up to a value greater than 1 or fall short of 1. For this reason, the values stored in array prob should probably be better referred to as strength values rather than as probabilities. The rules of probability are only used to combine those strength values within individual rules. As well as the code for the editor and the expert system framework itself, I've uploaded to my website a sample set of rules. I thrashed these out with an acquaintance of mine who plays some sort of spaceship role-playing game, a bit like Dungeons and Dragons in space, apparently, as we thought it would be an idea to see how an expert system could be used to diagnose serious faults on board a starship. The example I give is a simplified version of what we came up with, and I thought it would be a laugh to go through a sample run-through here on the channel.
Captain, there seems to be some sort of fault with the ship.
I see. Perhaps the computer can work it out. Let's see. Engine room, tell me, is the reactor core temperature rising?
Not really, Captain. Maybe a little warm, but nothing we cannot handle.
In that case, I'll give it a score of 0.3. Mr. Spoke, has any radiation been detected on E-deck?
I have no information on that, Captain. Nothing to my knowledge.
In that case, I'll have to give it a score of 0.5, to indicate that I don't know. Scotty, can you hear a high-pitched whine at all?
Aye, Captain. I assumed it was the new interns, 'cause they're always whining about something, but they're all on shore leave.
I'll give that a score of 0.8 then. What about the power cells? Are the energy levels falling?
Aye, Captain. Going down like a Sassenach soldier at the Battle of Bannockburn.
That earns a score of 0.9. Now, can anyone feel anything vibrating around here?
Negative, Captain. Ach, no. Well, maybe a little now that you mention it.
I'll give that a score of 0.7. Finally, what about power failures? Have there been any power failures?
I'd call that a big yes, Captain.
Well, be fair, Mr. Spoke. That's the first time that's happened in 106 episodes. I'll give that a score of 0.6.
So, what conclusion does the computer draw, Captain?
Apparently, the most likely cause is a compressor coil failure in the engines. That's no biggie. We can put in for repairs the next time we're in dry dock. I suggest that we don't need to get our faces in a twist over this. Oh well, it doesn't always work.